Dear students, under the lecture series on complex analysis, here we have the second problem under the topic Taylor series. We have to expand the function f of z is equal to 1 by z into a Taylor series about the point z equal to I, and should also determine the region of convergence. Now we see that f of z equal to 1 by z. We have already done this problem about the point z equal to 1. So if you see in our previous problem, we have expanded f of z equal to 1 by z into a Taylor series expansion. But we have done it about the point z equal to 1. Now instead of z equal to 1, we have z equal to I. And so the region of convergence also we have to find accordingly. So now in order to do that, first we shall write the Taylor series expansion. So the Taylor series expansion is given by f of z is equal to f of z naught plus f dash of z naught by 1 factorial multiplied with z minus z naught plus f double dash of z naught divided by 2 factorial multiplied with z minus z naught the whole square plus f triple dash of z naught divided by 3 factorial multiplied with z minus z naught the whole cube plus etc. It goes on like this. So now next we have to find f of z naught, f dash of z naught, f double dash of z naught and f triple dash of z naught, and we have to substitute over here. Here the given f of z is 1 by z. So let us write that f of z is equal to 1 by z. And this is about the point z equal to I. We have to find the Taylor series. So that gives us the point z naught. So z naught is equal to I. So having this, first we shall substitute in this equation. So when we make the substitution, f of z as 1 by z, we get 1 by z is equal to f of z naught. So f of I, and then plus f dash of I divided by 1 factorial multiplied with z minus z naught, which is I, plus f double dash of I divided by 2 factorial multiplied with z minus z naught is what? I, the whole square, plus f triple dash of I divided by 3 factorial multiplied with z minus I the whole cube plus etc. This goes on. Now we shall find f of I, f dash of I, f double dash of I, f triple dash of I, and we shall substitute here. For that, first we should take and write f of z. So f of z is equal to 1 by z. And from this we have to find f dash of z, which is the differentiation of 1 by z, and we know that it is 1 by minus 1 by z square. And next we have to find f double dash of z, which is equal to, this will be raised to the power minus 2, and so minus into minus it will become plus. So 2 z power minus 3 we will have, and so 2 divided by z to the power 3. Similarly, f triple dash of z also we have to find, which will be z to the power minus 3, and so on differentiation 3 2 times is 6, and we will have a minus sign, so minus 6 z power minus 4, so it will be minus 6 by z to the power 4. So these are the differentiations with respect to z. Now we shall find the corresponding f of I, f dash of I and f double dash of I, like that. So from this we get f of I to be equal to, so at the place of z we have to put I, so it will be 1 by I. Similarly, from this f double dash of I will be equal to minus 1 by z is what? We have to put I, so it will be I square, that is equal to, we know that I square is minus 1, so minus into minus it will become plus, and we will have 1. And from this f double dash of I we have to find, so that will be equal to 2 by I cube, that is equal to 2 by I cube can be written as 2 by I square multiplied with I, which is equal to I square is minus 1, and we will be having 2 by I minus I, actually that minus I will write here. And next we have f triple dash of I, which is equal to minus 6 divided by I power 4, which is equal to minus 6 divided by I power 4 can be written as I squared multiplied with I square, which is equal to minus 6 divided by I square is minus 1, I square is minus 1, when multiplied it will become positive. So this is equal to minus 6. So now we shall substitute each of this in this expansion. So the Taylor series expansion becomes, so on substituting, 1 by z is equal to, what is f of I? It is 1 by I. So we will write that 1 by I. And then f dash of I is, we have here actually this is f dash of I. So that is equal to 1. So 1 divided by 1 factorial, so it will be 1 only. So plus z minus I. And then f double dash of I is minus 2 by I. So minus 2 by I multiplied with 2 factorial, which is 2 only, multiplied with z minus I the whole square. And then we have f triple dash of I, which is minus 6. So minus 6 by 3 factorial is 6, multiplied with z minus I the whole cube, plus etc. It keeps on going like this. So 6 and 6 gets cancelled, 2 and 2 gets cancelled, and so the series is 1 by z is equal to 1 by I plus z minus I, and then minus z minus I the whole square divided by I, and then minus z minus I the whole cube, plus etc. It goes on like this. So now after finding this series, we have to find the region of convergence. So as seen in the previous problem, in order to find the region of convergence, we should know where the function is not analytic. So we know that f of z equal to 1 by z is analytic everywhere except at the point z equal to 0. Now using this, we find the region of convergence. So we know that the region of convergence is modulus of z minus z naught less than r. But we should know what is r. So what is r? R is the distance from the center z equal to 1 to z equal to 0. Here this was for the previous problem. But here what is z naught in our given function? Here the z naught is I. So r is the distance from I to z equal to 0. So if you see r, the distance r is equal to modulus of I minus z equal to 0 is 0. So that is equal to modulus of I. And we know that modulus of I is equal to 1, because we know that modulus of x plus iy is equal to square root of x square plus y square. Here we don't have the real part. The imaginary part is 1. So what is square root of 1 square? It is 1 only. So therefore the radius is 1. So therefore what will be the radius of convergence for this problem? So therefore the region of convergence will be modulus of z minus z naught. Z naught is what? I. So z minus I lesser than r. R is also 1. So here we have 1. So this gives us the region of convergence for the given function f of z equal to 1 by z, which is in Taylor series expansion about the point z equal to I. So when it is about the point z equal to I, the region of convergence is z minus I, modulus of z minus I lesser than 1. So go through this problem patiently, you will definitely understand the problem. Kindly follow the upcoming video lecture for more problems under this topic. Thank you.